Hey, Topic Life Math and History, and we are going to be taking a look at the vertex form. So, as a warm-up, let's graph something. Graph the equation to distributive property x minus 3 squared plus 1, and find the analyzations right here and analyze what it'll look like on the graph. So, let's get started. But wait, what kind of equation is this? And where did this even come from? And how do we find these in the first place? Well, what this kind of equation is a little bit different. Because in the past videos, we have been learning about quadratic trinomials. And we've always been seeing this one. Ax squared plus bx plus c. This is called quadratic standard form because this is the most common form when you look at quadratic trinomials. You see, so these happen the most, but the one you just saw with this one is a bit different. We are going to be learning today that is a distributive property, x minus up by h squared plus k. And this formula is a little bit different because this one's called the vertex formula. Another way of thinking it. So what we want to do is we can move this formula and transform it back into its standard form. Let's see what happens when we try to put it in its standard form. Okay, so we have the equation that looks like this. The first thing you want to do is you want to try and find out what the quadratic trinomial is. So let's start with the parentheses first because of order of operations. So x minus 3 and x minus 3 because of that square right there. When we do that, we're gonna get x squared minus 3x minus 3x plus 9 when you multiply the numbers out or FOIL the numbers out. These two become negative 6x. So x squared minus 6x plus 9. We still have to multiply everything by 2 and add that 1 because that 1 was right down there in the first place. After we do that, we get 2x squared minus 12x plus 19 because of you multiply 2 times x squared, 2 times negative 6x, and 2 times 9. But then you have to add by 1. So here is a quadratic trinomial. When we learn how to graph the quadratic standard form, we can easily graph that. But this took like 2 minutes of the entire video. There's a new method that we are going to be doing so we can get through this video and get the job done a bit faster. And it will help us understand more what the graph will look like instead of doing an extra step of boring math. Well, math that takes a long time before you can actually start the actual math. So what we did is, we did find the quadratic trinomial. We could graph that, but that's a little bit of an extra step. What we're going to do is experiment. We are going to use these equations listed right here and try and find out with the analytics, what is the angle of symmetry? What's the vertex? What's the Y-intercept? What if it's up or down? And if there's a min or maximum. We are going to be experimenting with these equations and looking on them in Desmos. Because Desmos is a calculator on a computer that will visualize what the parabola will look like. Okay, so we're not going to do the top one because that's the formula. We're going to type in y equals 3 distributive property, so shift x minus 2 parentheses squared, so we have to do this squared, this squared, plus 6, and see what happens. Let's list down the rest of them and also see what happens. But right now, we have a parabola that looks like this. Let's start the other ones. Y equals
2 hours later. Meanwhile, 8:01 p.m.
So I guess that took a little bit of a while. So here are the equations on Desmos. And this is what the graph looks like. And when we do that, we put many parabolas on the graph. And we're going to explain what the analytics are. So let's reveal what the vertex is for each of the equations. So let's see what happens. The vertexes are, here we go, 2, 6, 3, negative 10, negative 24, negative 5, negative 2, negative 1, and 4, comma 3 as a point. So when you find the vertex, there's actually a pattern that can help you find the vertex really, really fast. If you look back at the vertex form or the equation, you realize that your last character, like k for example, let's circle k, your k is always going to represent your y variable for your vertex. But what happens to the x variable? With the x variable, you can realize that here's negative 2, positive 2, negative 3, positive 3. So when you see that, like negative 4, positive 4, your x is this number, but it's the opposite of that number. When you have a negative, it will become a positive. But when you have a positive, it will draw to a negative. So your x is going to be the opposite value of your x in here. So when we see that pattern, we realize that the formula is hk because we have y equals a parentheses x minus h squared plus k, and we have that negative h. We're going to turn that into a positive h for the formula for a vertex. So that is how you can find the vertex very, very fast. Let's see the second reveal. The second one is understanding if it's up or down. And this one's a little bit easier to identify than the vertex, because when you have a value of a that's bigger than 0, you are usually, well, you always have a parabola that wants to open up. If you have a value that's less than 0, you're going to have a parabola that's facing down or opens down. So when we do that, we want to look at our a value. Here's an example. All these are up except the last two because their a is bigger than 0 or a positive number. The last two is down because here's a negative 3 and a negative 1 over 7. That is less than 0. So always look at your a value to understand if your parabola is going up or down. Let's look at the third reveal. The third one is the width of the parabola. This one isn't not always required in schools because you can have different opinions on, oh, this is wide, oh, this is narrow, this is skinny, or, yeah, or this is super skinny. Many people have different opinions what their parabola looks like and how wide it is. But there's something that we can identify. Just like the up and down part, this also has to apply with the letter A. Because when your A value gets bigger and bigger and bigger, your parabola is going to look smaller and smaller and smaller. But when your A value is less than 0, which your A value is smaller, then it's the opposite. Your parabola will get bigger, 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 or wider, wider, wider. Because the black parabola is more wider because it has a negative number and is less than 0. The red parabola, however, is a little bit more narrow because it's a positive number and it has a number that's greater than 0. So that is understanding the width of it. Let's look at another one. This is the final reveal of the night, the Y-Intercept. The Y-Intercept, however, cannot be directly given from the Vertex Formula. So literally, we are gonna have to plug in 0 for every equation, which we won't do, but we will in our example problem. And when we do that, we'll find out what y is and understand what the Y-intercept is. Unlike what we've been learning in the past with ax squared plus bx plus c, or quadratic standard form, you can immediately understand that c is the Y-intercept in this case scenario. But you can't. That's why they have a letter K in the formula instead of a C. Because that tells you you can't find the Y-intercept unless you actually do the math. Well, actually, let's do the math.